Hello. Water treatment and environment. Water is the most vital resource for all kinds of the life in this planet. According to source, the water environment can be subdivided as freshwater and the marine water environment. 70% of the Earth's surface is covered with water. However, the prime importance is the 1% that is valuable for human use. Water is used for drinking purpose as well as the many other works. To produce 1 ton steel, about 2,15,000 water needed. Hence, that is the need of effective water management. Okay, to produce 1 ton steel, about 2,15,000 liters of water needed. Hence, there is the need of effective water management. Although several conventional water treatment technologies like chemical treatment, mechanical separation, ultraviolet radiation, biological treatment, desalination are available in the markets are expected to have a few distinct advantages for large-scale application to economize and perform with greater efficiency. Nanotechnology can contribute to effective water management in many ways. Some of them are as following: nanomembranes and nanoclays for water filtration and desalination, nanoparticles activated wastewater reuse system, nanosensors to monitor water quality against bacteria, heavy metals, and toxins. Okay. Nanosensors to monitor water quality against bacteria, heavy metals, and toxins. Nano-enabled water treatment technologies include the use of nanomembranes and filters based on carbon nanotubes, nanoporous ceramics, magnetic nanoparticles, and other nanomaterials. It has been shown that nanofiltration, which can lead to remediation, correct brackish water, seawater. The use of nanoparticles for treatment of water are explained in different points shown below. Carbon nanotube-based water filters have been found to be effective tool for nanofiltration. Carbon nanotube functions as a molecular filter and allows water molecules to pass through them. Molecules that are bigger than the diameter of the carbon nanotubes are filtered out. Carbon nanotubes membranes can reduce the cost of desalination significantly. It is reported that the use of nano-titanium dioxide in magnetic nanoparticles can decompose organic pollutants and remove salts and heavy metals, enabling wastewater reuse. Different molecules can be separated based on their size during nanofiltration using membranes in industrial process. Nanofiltration is applied for the removal of specific components such as coloring agents. Other applications of nanofiltration are removal of pesticides from groundwater, removal of heavy metals from wastewater, water softening. Nanotechnology is expected to result in economic solutions capable of reaching a wider cross-section of people. For effective remediation of contaminated water, particularly for removing heavy metals ions, various nanoparticles and nanomaterials like zeolites, carbon nanotubes, biopolymers, single enzyme nanoparticles, bimetallic iron nanoparticles, and nanoscale semiconductor photocatalysts are used. Removal of pathogens from water is essential to avoid several waterborne diseases. The use of nanomaterials like silver and titanium dioxide with antimicrobial characteristics can provide viable alternative to the use of chlorine. Air pollution can be monitored using nanotechnology with filtration. Nanofilters can be applied to automobiles and other exhausts in industry to filter out contaminants before the exhaust gases are let into the atmosphere. So that build of greenhouse gases in the atmosphere is prevented. Nanosensors can also be developed to detect toxic gases at very low concentration at atmosphere. Nanocatalysts can be used in the catalytic converters in automobiles to remove the contaminants and increase driving performance. Okay, it's all about water treatment and environment. Thanks for watching and request you all like, comment, share and subscribe. Thank you for patience. That is now bye bye.